All right, so geometric mean is a vocab phrase that I'm going to be using. What geometric mean is it's the square root of the product of two numbers. So if I ask you, what is the geometric mean between 7 and 2? You would do the square root of the product of those two numbers, 7 times 2. So the geometric mean between these two numbers is the square root of 14. So the reason why we're learning about geometric mean is because it does have to do with something related to similar triangles. And so we're going to use that figure that we saw in the last video. I'm going to try to recreate that figure here. So I have this triangle. I'm going to label it triangle ABC, or ACB actually. And then I had this altitude that created point D. And then using that figure in the last video, I have Y, I have X, I have B, I have H, A, and then this whole thing is C. Okay. So, basically, the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the two segments of the hypotenuse. So what I mean is that altitude, H, is equal to the geometric mean, which means the square root of the product of two things, and it equals to the two parts of the hypotenuse, X and Y. So H is equal to the square root of X times Y. We actually get that from one of our proportions that we created on this page here. This one. If I cross multiply, I wind up with an H squared is equal to an X times a Y. And so then to get H by itself, we would take the square root of both sides and we get H is equal to the square root of X times Y. That's how we get this equation here, is by using similar triangle proportions. And then there's two more equations. The length of a leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse adjacent to that leg. What I mean by that is, if I said I wanted to find this leg here, that is equal to the geometric mean, which means the square root of the product of two things. And those two things are the whole hypotenuse, which is C, times the part of the hypotenuse that A is adjacent to, so that's X. If I wanted to find the other leg, B, that would be equal to the geometric mean, which means the square root of the product of two things, and that would be equal to the whole hypotenuse, C, times the part of the hypotenuse that B is adjacent to, which is Y. We get these two equations from the similar proportion, or the similar triangle proportions that we created on this page as well. For example, we get it from the two that are boxed in blue. For the first one, if I cross multiplied, I would wind up with B squared is equal to a C times a Y. And then getting B by itself, I would take the square root of both sides, and I wind up with B is equal to the square root of C times Y, which is exactly one of the equations that we came up with on this paper. And then the other one, same thing. I'm not going to do this one, but if we cross multiplied and then took the square root, we would wind up with a is equal to the square root of c times x. So these three equations stem from our similar triangle proportions that I have boxed here. So now we're going to use the geometric mean to actually solve for unknowns in our problems on the next few pages. So for this one, we are trying to find a leg on my giant right triangle. And so if you're trying to find a leg, that's these two equations here. So that leg is equal to the square root of the product of the whole hypotenuse. Let me redraw that. My whole hypotenuse is 10 times the part of the hypotenuse that that leg is adjacent to, which is 4. So I wind up with x is equal to the square root of 40. We are going to simplify this radical. The largest perfect square factor of 40 is 4. The square root of 4 is a 2, and we're left with 10 underneath my radical. 2 root 10 is your value for x. Looking at my next one, it's probably helpful to find x first. We can find x by using the altitude. The altitude is using this equation here. So the altitude is equal to the 2 parts of your hypotenuse. So the square root of 20 times x. Now when there's a variable underneath your square root, to get it out of the square root, what you do is you square both sides of your equation. A 10 squared is a 100. And the square root of 20 times x, all that happens there is your square root goes away, so you're left with a 20 times x. And then, dividing both sides by 20, I wind up with x being equal to 5. Now I can easily find y and z. As if I have x being 5, I now can find my whole hypotenuse, which is 25. And so finding y, I would do y is equal to the square root of the product of my whole hypotenuse, 25, times the side that it's adjacent to, which is 20. To find z, I would do the square root of the product of my whole hypotenuse, which is 25, times the part it's adjacent to, which is 5. All right, so if I do 25 times 20, I get a 500. So y is equal to the square root of 500. The largest perfect square factor of 500 is 100. 100 times a 5. The square root of 100 is 10, so I pull that out. The square root of 5 cannot be done, so that stays in. Now z is pretty simple because 5 does not have a perfect square factor, but 25 is a perfect square. I can automatically just simplify this right away. So the square root of 25 is a 5. I'm going to pull that out. And the square root of 5 cannot be done, and it does not have any perfect square factors, so I just leave it as 5 root 5. Okay, moving on to the next page. Okay, so I'm going to start with x. X is my altitude. The altitude is equal to the square root of the product of the 2 parts of your hypotenuse. So 3 times 6. So x is equal to the square root of 18. The largest perfect square factor of 18 is 9. I'm going to split 18 up into a 9 times a 2. The square root of 9 is a 3. The square root of 2 cannot be done, so x is 3 root 2. All right, moving on to y, we do need the whole hypotenuse, which in this case is 9. So to find y, that's equal to the square root of the product of the whole hypotenuse times the part it's adjacent to, which is 3. This one's pretty simple because 9 is a perfect square and 3 does not have any perfect square factors. The square root of 9 is 3, and that root 3 can just stay. Lastly, moving on to z. Z is a leg, so it's equal to the square root of the product of the whole hypotenuse times the part it's adjacent to. This one's pretty simple as well, because I can do the square root of 9 right away. And the square root of 6 does not have any perfect square factors, so we can just leave it underneath the radical. All right, moving on to 36. I'm going to find y first. You could have found x first, it doesn't matter. Y is an altitude, so it's equal to the square root of the product of the two parts of your hypotenuse multiplied by one another. Now you can do the square root of 4, however 8 has perfect square factors, so I want to keep going. I want to actually multiply 4 times 8 together to get 32. The largest perfect square factor of 32 is 16, so I have a 16 times a 2, that equals 32. So y is equal to the square root of 16 is 4, the square root of 2 cannot be done. All right. And then, now I'm going to find x. In order to find x, since it's a leg, I do need the whole hypotenuse, which the whole hypotenuse is an 8 plus a 4, or 12. So I have x is equal to the square root of 12 times this part that it's adjacent to, which is 8. A 12 times an 8 is a 96. The largest perfect square factor of 96 is a 16. A 16 times a 6 equals a 96. The square root of 16 is a 4. The square root of 6 cannot be done. 4 root 6 is your value for x. All right, looking at 37. Let's find x first using this leg. This leg of 6 is going to be equal to the product. Actually, I'm going to find y first. I apologize. The product of my whole hypotenuse times the part that it's adjacent to, which is 4. I have a variable underneath the square root. To get that variable out, I need to square both sides. A 6 squared is a 36, and the square root of y times 4, the square root just goes away, and I'm just left with a y times a 4. To solve for y, I just divide by 4 on both sides, and I get y is equal to 9. Now, I don't really have to do much work to find x, because if my whole hypotenuse is 9, and a part of it is 4, to find x, I can just do 9 minus 4, and that leaves me with 5. Why do more work than we have to? We do not need to do a geometric mean for that one. All right, this next one's a little bit complicated. We have our s being 32, so we do have the whole hypotenuse. We want to find the altitude, but in order to find the altitude, we need to be able to find, I'm going to label RT y and TS z. We need to be able to find y and z. But there's a way that we can do this without using y and z. We could just use the variable y. If RS is 32 and RT is y, then that means that I can label TS 32 minus y. Now, if I use the altitude, that would give me 2 variables. So let's actually use this leg first. I'm going to have you pause the video and use this leg to help you find y. So using this equation, we get y is 2, so that means RT is 2, TS is 30, not drawn to scale. Now I'm going to have you pause the video to use those two to help you find x. All right, you wind up with 2 root 15. Now we already did 39 and 40. Those were the first two problems we did. I don't know why I have them on there twice, but on yours it is fixed, and that is the end of this lesson.